Good morning, guys. Either you're watching this on Sunday or scurrying around and watching it on Monday morning. This will be posted till about 10:30 on Monday. All right. This we took a brief dive into pointers at the end of last semester, and instead of just starting from there, I decided to go ahead and do a review of what we talked about because I always found pointers confusing. As a matter of fact, when I still look at them, it's not anything that just fluidly jumps off the screen at me. I have to concentrate. So I hope that you all are giving this some concentration and not just letting the video run while you talk to your friends or eat breakfast or something. Just take some concentration. I would suggest notes. There's not a lot of code here, so taking these notes would be really easy to do and help immensely on quizzes, midterms, and finals, which there will be several questions off of these. You'll notice that this is really ripe for material for quizzes and tests. All right, the first one is just, like I said, this should be a little bit of a review. It should look at least familiar to you. All right. Number one, program number one for pointers. Nothing going on special up in the above main, just IOStream and namespace. It doesn't take any special header files. Inside of main, I declare an integer x and assign it the value of 25, which is something we learned on probably our first day of class. Now I'm going to do three couts to kind of show you what's going on behind the scenes of this simple little line int x equals 25. First thing I'm going to do is cout the address of x. Address of x is just the ampersand and x. When I cout an address, it's going to be in hexadecimal value. It's going to be strictly it'll strictly apply to just your computer. If you and everybody around the classroom runs this program, you all will get different addresses, all right? Because when you declare a variable x, you cut out a part of memory and make that x, all right? So this is going to cout the hexadecimal value of that address. Second cout, we're going to cout the size of x. On my computer, this is going to cout 4 bits. When I declare an integer x, it sets aside 4 bits of memory. This is size of. Last week I think in our programs, I showed everybody how to use the size operator, where I use size when it comes to string array or strings. This is size of, and whatever you put inside there, whatever variable you put inside there, it shows you, it'll cout the size in bytes of that variable. If I cout a string, it's going to be much longer than an int. If I cout a character, I believe it would be shorter in bytes, but this is just going to return an integer number of the number of bytes for integer x. And the final one is just to cout the value. Right? You can see right here, all I'm doing is coutting out x, which is going to be the value 25. I hit local Windows debugger. All right. The address of x is, there's your hexadecimal address, 00CFFEC. And we'll talk about more later on what this means, but for now, you just need to know that this is the address. The size of x is 4 bytes. I think that's what you would get on each of your computers if you run this. I can't see that any of your computers running this and making it 2 bytes or 1 byte. And the value of x is 25. All right, again, there's the code. I'll let you take a peek at it real quick. Pause this if you need to. it's important that you know what the address of X, the size of X, to understand those. All right, here's program number 2. Again, not much above main. I'm going to assign an int variable X equals 25. Now here's where we get to something that might be new and foreign to you. All right, I'm going to declare an integer pointer, a pointer variable, and I'm going to name it pointer. All right. And then I'm going to assign it null pointer. Null pointer just means it's the equivalent of assigning a 0 to an integer. Null pointer just means this isn't pointing at anything. All right? It's not pointing at anything. This asterisk means I'm going to make it a pointer variable, and it can point to an integer. It can only point to an integer. All right, this next line, pointer equals ampersand X. That means this pointer is going to point, this pointer variable is going to point to whatever's at the address of X. In this case, it's going to point to X, which has 25 in it. It doesn't mean that pointer equals 25. It means it points to the address of whatever's in X. That's hard to wrap your head around, but store the address of X in the pointer. This is so we can change things directly and indirectly, and you'll see as we go along here with this. All right, now I'm going to print this stuff out. The value of X is, and this is normal, this is what we did before, it's going to print out 25. The address of X is pointer. Remember, pointer is pointing to the address of X. All right, so hex is going to give a hexadecimal value. This next one, the address of X is the address of X. So both of these are going to say the same thing because pointer is pointing to the address of X, and obviously the address of X is the address of X. These are going to say the exact same things. All right, they're both going to give you a hexadecimal value. So what we've got here is we're going to have this line is going to see out 25. This line is going to see out the address of X because pointer is pointing to it. And this is going to see out the address of X. Right, the value of X is 25. The address of X is, maybe I should have said the pointer is pointing to the address of X at, but there's the address and there's the address of X. But remember, it's in two different ways. The second one was ampersand X, and this one was asterisk pointer. Let's go back and look at that real quick. I'm sorry, this just says pointer. And that's, I made a mistake. This is just pointer when I said that. So address of X and pointer. Let me go ahead and tell you why I made a mistake. If this had said asterisk, I'm going to go ahead and run it. I'm going to do this, change this. Look at this. I'm going to see at asterisk pointer. Just pay attention to the code in the middle. It sees out 25. Here's what this is. This says this is going to see out what's pointed to by pointer. I'm going to get rid of this asterisk and run it. Pointer is just the address. When you put an asterisk in front of it, it's what's pointed to by it, what's inside there. So look at that. That's 25 when I put asterisk pointer. When I get rid of that pointer, It's an address. I'm going to do it again because I can't stress this enough. Asterisk pointer is going to what's pointed to what's inside of X. Think of it like that. What's pointed to inside of X with this pointer, it's going to give you the value. You get rid of this asterisk, and it's just going to give you the address. Because look what this is. This is the address of X equals pointer. So when it's like this, it's the address. When I put the asterisk in front of it, I know I keep going over this, but it's important. It's what's in it. It's what's pointed to by. Okay. That's really important. And that's actually the key to this whole lesson. So if you need to run that a few times or watch that a few times, do. All right, let's do the last program. All right, again, nothing up at the top, nothing special up at the top. I declare an integer x and assign it the value 25. Again, I make a pointer integer. I name it PTR, and I assign it the null pointer, which means it doesn't point. It's not pointing anywhere. And just like last program, the address of X, I'm going to assign to pointer. And this is what it would be like to change things indirectly. Okay, here's the value of X printed twice. All right, this way I'm just going to print out X. What you all did, I'm going to see out X just like we have before. This one is asterisk pointer, which is like I showed you in the last one. It's going to show you what's pointed to inside of X. So both of these are going to see out the same thing. 25 because X is 25, and asterisk pointer, okay, because it's pointing to what's at X. So they're both going to point to the 25. All right, everybody knows how to change the value of X. We just make it like X equals 100 or something like that. Here's how you indirectly change it. All right. So what's pointed to in pointer, what we're pointing to, we're going to assign it 100. What that'll do is that'll change the value of X. Remember, this is what's pointed to by pointer. In my notes, I put assign 100 to the location pointed to by pointer. This will actually assign 100 to X. I've left enough notes in this to where you don't even need the commentary. You could probably follow this without me explaining it. All right, now that I've assigned 100 to what's pointed to at X, let's see these out. Once again, here's the value of X. There's X. And there's the pointer, what it's basically pointing to X. So let's look at this. Here is the value in X, printed twice, 25, 25. Then remember how I changed the value, 100. It's asterisk pointer equals 100. So that changed what's at X. Once again, here's the value in X, 100, 100. This is the key line here. All right. Basically, what's pointed to by pointer equals 100. All right, so that assigns the value of 100 to X. Definitely give this a good hard look at. This isn't easy material because it's not real intuitive. It's something you need to study, you need to really look at. This gets to be important later on, especially when I know this will make some of you cringe, an even deeper dive into functions. You're definitely going to need to know this. We're going to spend the next 3 or 4 classes on pointers. So if you don't have a good, strong base, you're going to struggle a little bit with this material. Strongly suggest you take notes. Guys, if you are watching this on Monday morning, I hope you're giving it enough attention. I will see you all at Monday in class. I hope everybody has watched this. I hope you're all not you. I hope uh, I would wish that you all would make sure your other classmates text around that they're watching this. I'd hate to see people using their mulligans early on. I sent this out in an email, so everybody should know about it. All right, guys, have the great rest of your day. I will see you on Monday.